Part 2 now after the first exam. We are in chapter 3 talking about derivatives, and today on the menu kind of mildly spicy trig derivatives. So we'll start with the notion of trig pairing first for calculus, and then we'll work our way through the formulas. In terms of proofs, again, this is not an honors section. All of the proofs that you might want to know are in the book, and I can explain if you're interested. We will be using, again, the limit definition of the derivative, which is the limit of h goes to 0 of f of x plus h minus f of x over h to prove, and for that we will have to define / memorize two specific limits, which we find out how to solve later on in chapter 4. So now it's pure memorization. So let's first go through these trig derivative pairs, so we know which function goes with which function. So we start by making a sine x cosine x pair. Then we have tangent x secant x pair and cotangent cosecant x pair. This is not minus sign, this is like a hyphen, just to pair them together. And as you see derivatives later on, they're always in these pairs. For instance, derivative of tangent will be secant squared, derivative of cosecant would be cosecant cotangent, so negative cosecant cotangent. So they are always in these pairs. And even in chapter 4, when we get into integration, which is antiderivatives, in the last section 4.9, when we define the basic integrals, these pairs will be, again, the same because integrals will be backwards derivatives. So what are we doing with this? Well, it's just remembering the new set of formulas so that we don't have to crank the limit definition every time we have to take the derivative of sine, cosine, or whatever function, which is very frequent in our sciences. Trigonometric functions are periodic functions, so we can use them to model a lot of data. If you took Precalculus 2 course, you know how many applications are there in physics, in waves. They're everywhere. So we really need to know a lot of trig to do a lot of quality engineering of technically any type. So now, the two limits that you are supposed to memorize, because they are, as I said, explained, and why are they what they are in chapter 4, are the limit of sine x over x and the limit of cosine of x minus 1 over x. So those two limits, and if you memorize those two limits, then you will be able to understand the proof of why the derivative of sine is cosine and so on, because you will be able to compute that using the limit definition. So in the textbook, they're asking you to memorize that the limit as x goes to 0 of sine x over x is equal to 1, and that the limit x goes to 0 of cosine x minus 1 over x is equal to 0. So these two limits, they ask you to memorize. Now again, if you are not going to go and memorize and learn the proofs for this, these limits will be back in chapter 7, and you will actually learn and know how to do them. So, but at least I listed them, so we won't have any issues there. All right, so what are the things that you must memorize? You must memorize that the derivative of sine x is cosine x. Very good. You must memorize that the derivative of cosine x is negative sine x. Exactly. You must memorize that the derivative of tangent x is secant squared x. And that the derivative of cotangent is? Yes. And what would be the derivative of secant? Sorry, yeah, secant x. And the derivative of cosecant x is? Great. All right. So now, I'm going to briefly touch upon the symmetry in mathematics. You've probably heard, if you listen to any of the talks on modern physics or mathematics, something, they would sometimes mention the symmetry in equations and so on. So here is a perfect example of what that means. Look, we have the pairs, right? It's always sine with cosine, tangent with secant, and cotangent with cosecant, so they're always paired, and that goes throughout. Now also observe this, that you have the same form. See, the sine and cosine are pairs, right? You have sine with cosine, cosine with negative sine. Now look at this tangent, secant, cotangent, tangent and cotangent, right? They're kind of not the same, but they're reciprocals of each other. And then look at these guys, right? And then same form here. And every time you have a co function, right, cosine, cotangent, or cosecant, it's negative on the other end. It's very easy to remember this if you actually sit down and stare at this for some time. You will figure out that it's sufficient to learn 3, and the other 3 are negatives of those. Very simple. So you will be remembering 1, 2, 3, and if you know those 3, the other 3 would immediately be there. But that's only if you spend enough time to actually do this the right way. These are the basic ones, and once you know this, the only thing that we need to do is to do 2 things. Number 1 is to get derivatives of more annoying questions, because we can, put these in the product rule and the quotient rule and write those kind of things. And then the second part is to find the tangent line, which is the most important problem of calculus 1. So whatever the derivative gives us, right, at the other end. So technically this section is extremely short because we are not introducing any new concepts. You have the formulas that you are learning now. Those are the new shortcut formulas. And I don't think that Larson book actually has the section on this at all. It's just a part of whatever the basic thing is, lesson on taking derivatives, because it's just, this is the same like learning the derivative e to the x is e to the x. That's all it is. So now what are the problems? Probably modification that you might want to pay attention to, but we will learn how to do this by hand. If not today, then next Saturday. How much is, let's say, derivative of cosine of 10x? It's going to be 1 over 10, well, negative 1 over 10 sine 10x. The book does give you this as a formula as well, if you have a number in front of x, and that's going to go for all of these. But you really don't have to memorize it that much now, because we're going to learn chain rule, and the chain rule will take care of this situation when you have ax. It is negative 1 over a sine ax. And you can just go throughout the entire list up there of all 6 and change, put a in front of x and just put 1 over a in front of each one. Not 1 over a. Oh my God. It's a. It's supposed to say negative 10 over here. It's 1 over a for integrals. One 1 over a for integrals, and just a in front is for derivatives. But just don't worry about it. Don't worry about it. We are going to have the entire section devoted just to these kind of calculations, and we will have them clear at that point. So if you don't get to it today, definitely next Saturday. Now let's take a look at fun problems. A fun problem might be to find the derivative of sine x plus x cubed minus 9. Yes.
Minus cos x plus bx squared.
Close. Derivative of sine x is?
Oh, yeah.
Yeah. You'll be that. Exactly. Let's take a look at a slightly spicier example. What now? Anyone? Just say it, guys.
X squared c squared x plus 2x tan x.
What did you just do? Product rule. Thank you. So last class we learned the product rule. Copy the first function, take derivative of the second function, plus copy the second function times the derivative of the first function, and write it out in factored form if you can, which would kick x out. And that would be the end of the story. Here's the cool proof. I was literally thinking of saving this one for the exam. What does it say there? Show the derivative of tangent is secant squared using quotient rule. So I'm not asking you to do the limit, I'm asking you to do the quotient rule. say something, but I'm going to stand next to Howard. Then I need to know. It's quotient rule. What's the square? Divided by the square.
I did try. And I just get
All right, so let's take a look. We write tangent as what? Sine over cosine. So we are supposed to find the derivative of sine x over cosine x. So we unleash the quotient rule upon it, which is cosine x times the derivative of sine, which is another cosine x, minus copy the sine x times the derivative of cosine, which is negative sine x, divided by cosine squared x. So this is cosine squared x plus sine squared x over cosine squared x, which is 1 over cosine squared x, which is? Yes. Awesome. And now I have a challenge question that I would like you guys to I have a challenge question for you. Let's see how you do. Ready? What is 739th derivative of cosine x?
So even is negative sign, so odd is. I'm on the right track. I lost myself.
Have fun.
Yeah.
What is it? Negative sine x. Because the previous one was cosine x, and the one before that was sine x, and the one before that was. And when you do it 7 to 9 times, just do it. Or you did it somewhere else. Up to now, no. sine x, and it's an odd number, so it would still be negative. I don't know if that makes sense. I don't know. I'll be back. I gotta cycle this. Think about it. And I'm back. We're done thinking. Yes. What?
It makes cycles after the point where we go back to the
Very good. It cycles. It cycles and it eventually resets itself, and you said after 4. You take 4 derivatives and then it resets. Good. Just like those cubes, you know, when you cube, you get it solved. This other one? Was it the second one? Yeah. Okay, so how about you take, let's say, 8 derivatives. Take a look at the pattern and see if that could help you with it. Just write down. This is the part where a lot of people go like, what the hell am I gonna do? Just start writing. It's if you want to win a chess match, just like you sit down and just you want to win, right? No, you gotta think, move, and then you observe the other move, and then think about 5 steps ahead. Play chess. Not if I can't win as soon as I sit down.
I'm sorry. Well, I'd rather die than lose my coffee, so.
One side of it. I can extend it. No. We want to go home and sleep. Sometimes we get home like 3. Come on. They just started. For some. No, you can sit sleeping.
Yeah, I've been waking up like a half hour. I've been on the stretch for about. Yeah, no, I can. I tried. And then I can like swim within like 3 days. Not expecting.
Like he sleeps when he passes out.
Exactly.
Like driving and then.
That hasn't happened yet. Yo, on Mondays, I'll sleep for like 12 hours. Sunday and Monday, I'll sleep for like 12 hours. Between work and this class that I'm doing. And my class yesterday. Yeah. I've heard. I already tried to
I did the same thing when I was
now it's 20. It's no longer the same. Now you have to sleep every day. This is a two-way street. I remember the day when I was 16, went to a show in a different country. Didn't sleep 2 nights. Passed out in the park. Now, 1 night no sleep is okay, but 2 nights, I don't know. Sometimes you have.
The homework for 2.4
Wow, November 4th?
Yeah, but it takes so long not to finish by
Apparently the homework is open till November 4th. Really? I will send an email. Yeah. Yeah, by sending an email. We don't want that to be that much stretch because we will be in chapter 4. Also. All right, 739 derivative. We start with the original function, which is f of x, whose form is just cosine x. And then we go with the first derivative, negative sine x, and the second derivative, negative cosine x, and the third derivative, yes, sine x. Now, the derivative of sine x is cosine x, and you see that on the fourth derivative, notation changes, guys. On the fourth derivative, we have cosine x again. And then it shouldn't take too many brain cells to see that this is going to repeat. So it's just going to go like this forever and ever and ever and ever and ever and ever. So that means that every time when the number, the derivative number, is divisible by 4, because look at the 8th derivative, is back to original function. And then the 12th and 16th and 20th. So every time when it's evenly divisible by 4, it's going to be the function itself. So 739 is 1 less than perfectly divisible by 4, which means it has to be here, right? Which numbers are divisible by 4? Those whose last 2 digits are divisible by 4. 739. 39 is 1 less than 40. 40 is divisible by 4 perfectly. So that means that this position here would be 740th derivative because it's evenly divisible, which means that one before that one is the 39th. So 739. I can ask 1,073,4439. It will be on the same spot. It really doesn't matter what is to the left of 39. And whatever you come up, it's technically these 2 numbers here that govern which location the derivative is in. Have you seen this before anywhere? Something like this happening. Anyone remembers it? Anyone? This kind of cyclic thing. Multiplication of something. Squaring, cubing, to the 4th, to the 5th, to the 6th power. i's. Yep. Imaginary number I. As you start squaring, cubing, then the 4th degree, 5th degree, 6th degree, it behaves the same way. And that's the reason why this behaves this way. It's not a part of this course, but maybe you want to expand your mathematical horizons. Let's find some annoying question. All right, what's the second derivative? So find the second derivative of cosecant x. You leaving?
What is the derivative of cosine square x, right? Minus cosine.
You were talking about.
The derivative of
Oh, you have a different notation. You're writing cosecant as.
yeah, I write like this. Like
No, but you have to adjust that, otherwise no one will understand what you're writing.
okay.
So CSC.
Okay.
C, yeah, C, S, C, X. Yeah, that's it. And those are square brackets now. Yeah, oh yeah. You take the rank. I want to use your name. S, C, and then you have cotangent x. Good. And now you have to take the product, right?
Yeah.
So derivative of cotangent, you're used to it.
Yeah.
I know, me too. The derivative cotangent is
Minus cosine.
so the second derivative. We find the first derivative first. So you can label it f prime if you want to. The derivative of cosecant is negative cosecant x cotangent x. And now to find the second derivative, you can take the derivative of the first derivative, but we have to do the product rule. So copy the first one times the derivative of the second one, which is negative cosecant squared x, and then plus copy the second one, which is cotangent x, times derivative of negative cosecant is going to be positive cosecant x cotangent x. Now, to simplify this, I'm going to factor. I know that you guys would like to put these cosecant cubed and so on, but you can factor one of the cosecants. So cosecant x is factored, and we're left with the cosecant squared x plus cotangent squared x. Do we remember Pythagorean identities? Yeah, we do. Right, so. So we can't simplify this any further, but maybe you would have to change one of these. So I'm just gonna write over here somewhere, maybe on top. I'm just gonna write that the cotangent squared x plus 1 is equal to cosecant squared x. And then you see that you can replace that. So there are other forms in which this could be written over here. All right, 2 more problems and we are done with this section. And that is going to be find the equation of the tangent line for f of x equals to x sine x at x equals to pi over 3. Well, 3 is going to make you nice and ugly. I'm trying to ask her if she wants to do it. Yeah. So let's take a look. First thing is the derivative, so that we can find the slope as usual. Copy the first, derivative of the second, plus copy the second. Function derivative of the first is 1. We get the slope when we plug the value into the equation. So we have pi over 3 times cosine of pi over 3 minus sine of pi over 3. So that's going to be pi over 3 times 1/2 minus root 3 over 2. So slope works out to be pi over 6 minus root 3 over 2. Cool, right?
Wouldn't that be like pi over 3 plus pi over 2 plus?
Yeah, it's plus. I copied minus, I don't know why. I had it as plus in the derivative. Alright, so we have the slope. Now we need to find, we have x value, we have function, we can find y value. So let's first find y value, which is f of pi over 3, which is pi over 3 times sine pi over 3, which is pi over 3 times root 3 over 2, which is root 3 pi over 6. So y equals mx plus b. I have to find b. We have y, which is root 3 pi over 6, is equal to pi over 6 plus root 3 over 2 times x, which is just pi over 3, and then plus b. So I just shuffled these fractions a little bit around, and we'll get b. Root 3 pi over 6 is equal to pi squared over 18 plus root 3 pi over 6 plus b. Well, this is awesome that it worked out that way. So we have that b is equal to negative pi squared over 18. So y equals to slope m, pi over 6 plus root 3 over 2 times x minus pi squared over 18. There it is. I said it's going to be fun. Trig. I want more. I see. So I'll take one from the textbook because apparently you didn't like mine, right? So find tangent line also at pi over 3. Wow. What are the odds? And the function is cosine x divided by 1 minus cosine x. That's problem 65 in the textbook. Welcome to the math party, Trig party. My problem looks better than I really want in the book. Nice one.
No, stuff where I work before.
That sounds concerning. It was like this on the exam as well. Second exam, they have the same time.